and get started. The last session started a little late, so I want to be on time for this one. So just letting you know, this session is being streamed and recorded, so you can go back and watch this as many times as you want. I know your final is pretty much tomorrow, so this is kind of a last review here. I have to say, this is a review that I made. Dr. Patino has looked it over. I made this review. It's not sanctioned by him, whatever. So don't just use this to study. Use your notes, use your lecture slides, use everything else to study as well as this. Also, I am not going to get to every question in this. There are 81 questions in here. The answers are on the back, the last page, last 2 pages that go through. I cut this down from 150 to 81. So I will go over some ones, the first, a lot of them that I think are very important. The last half of this, I'm going to try to go over gas questions because I know there are 15 or 20 questions that are his. So I want to pick out questions that I think are important for those. And the last 20-ish minutes, I'm going to leave for questions, individual questions that you may have, group questions, depending on what you need. Okay? So let's get to it. Also, in between questions, I like to give students an opportunity to work with your neighbors to think about the solution to them. So I'll give you like a minute, maybe half a minute in between each question before I or somebody else, or pretty much I solve it. Okay? Are you guys ready to start? Yeah? All right, let's do it. Also, forgive me. This is going on hour 3 of doing this. So I had a review before this. So there. Question. This is online. It's on the Study Union WordPress site. Okay? The solutions are on the back. So if you Google UCF SARCs or UCF Study Union WordPress, it comes up. You can click Study Union materials can be found here. Click on that, and there it is. Under my name for 1B. There's also one for 1A. This is yours. Okay? Sound good? All right, let's go over this. All right, so the first question is, all of the following are physical properties of matter except, also I tailored these like ACS questions. They're, it's going to be a review of both Chem 2040 and 2041. So we'll try to start with the first half as being 2040-ish, then the second half getting into 2041. Okay? All right. So I'll go ahead and zoom this in and focus. So it says, all of the following are physical properties of matter except. All right? So we're looking for something that involves a chemical change, which is going to be the except. So we're looking for a chemical property. So mass, physical property. Color, physical property. Melting point, physical property. The ability to rust is a chemical property, so it is not a physical property. Okay? Also, if there are any questions, just raise your hand in between, and I'll try to get to them. If I don't see you, then you can yell at me. All right? Let's keep going. Which state of matter has a definite volume and takes the shape of the container? Okay? So take half a minute. Think about this with your neighbors. This is going back. Chapter 1 in the chemistry textbook. See that? All right, this one's pretty straightforward. Which state of matter has a definite volume and takes the shape of the container? So, does a solid take the shape of a container? No. Does a gas take the shape of a container? Yes. Does it have a definite volume? No. So, it has to be a liquid. Which of the following is a heterogeneous mixture? A heterogeneous mixture is made up of, you can see the different parts. So, heterogeneous mixture, steel, you can't pick out the individual elements. Air, you can't pick out the individual parts. Salt water, you cannot pick out the individual parts. So soil has to be the answer. Okay? All right, keep going. Which of the following is another heterogeneous mixture? So this one, if you guys want to yell out the answer, you're welcome. C, which of the following is a heterogeneous mixture? Oil and vinegar. Don't mix. A substance that can be separated into two or more substances only by a chemical change is an. It's a compound. An element cannot be separated. A solution can be separated, but not by chemical means. A mixture can be separated, but not by chemical means. So a compound has to be the answer. Which of the following is a chemical property? Color, hardness, freezing point, ability to react with oxygen. D, ability to react with oxygen. Okay, let's keep going. The closeness of a measurement to its true value is a measure of its accuracy. Good. Remember the example with the target. Closer to the bullseye is accurate. Closer together is precision. Okay? Cool. Can you guys see this? All right. Again, if ever you can't see what question I'm working on, yell at me and I'll fix it. So, if the temperature changes by 100 degrees Kelvin, how much does it change in Celsius? 100 degrees. Good. They're direct. Just shift it up. Okay? So, there you go. 100 degrees Celsius. It's the same. Yes?
I thought Celsius was Kelvin minus 250 degrees.
It is, but if both change 100 degrees, it's a direct relationship. So it's still changing that 100 degrees. You're not multiplying by a factor, you're just adding. Okay? All right, let's keep going. The particles that are found in the nucleus of an atom are protons and neutrons, right? Neutron. Remember the electron cloud? We'll get into more quantum stuff in a little bit. The atomic number of an element is the total number of which particles in the nucleus? What did we just say? Protons and neutrons. The atomic number, my fault, protons. Atomic number. I thought it said atomic mass. Again, I told you I'm going on hour 3 of doing this. Questions on this first page? Pretty simple, right? All right, let's keep going. Precision are closer grouping. You worry about the grouping. And accuracy is how close you are to the target value. Okay, no problem. Let's keep going. Let's see. Okay. An element has an atomic number of 76. The number of protons and electrons in a neutral atom of the element are. So the element has an atomic number of 76, which also means that's the number of protons, so it says 76. So the number of protons and electrons in a neutral atom of the element are. What? B? D, yeah, that's what I was saying. D, they're equal number, equal charge, okay? All right, I'm going to go ahead and skip ahead to number 15. These are pretty similar to the ones before. Isotopes of the same element have different what? Neutrons, good. They have different neutrons, number of neutrons, good. All right, I skipped ahead. If you have any questions before, ask them in the last 20 minutes. All right, let's go to 16. Which of the following set symbols represents an isotope of the same element? So what are we looking for when we're determining isotopes? Who said what? Same protons, different what? Neutrons, which means different what from the symbols? Different mass, good. So these are the only ones with the same number of protons and different mass. Okay? So that's how we look for isotopes. All right, let's keep going. Let's go down to 18. We can go ahead and skip 17. How does the energy of an electron change when the electron moves closer, or closer to the nucleus? This has to do with chapter 7. It decreases. Good. So, it decreases. It's not going to stay the same because the distance from the nucleus is changing. It's not going to increase because the further away it is, the more energy the electron has. And it doubles. We have no idea if it doubles or not. Okay? It's not going to double. If anything, it'd be halved. Questions? Like I said, also, it's okay to ask questions. You're okay to stop me. That's what I'm here for. All right. Let's take a look at number 19. What is the shape of the 3p atomic orbital? Okay. So let's go through. In our quantum numbers, when we were learning about electron clouds, what is the shape of the n orbital? Or S, my fault. 1s. It's a sphere in the center. Good. In this case, the p orbital, what does it look like? Dumbbell. Good. How about the d orbital? It's the it's called the rows, or four-lobed star, or four-lobed rose, whatever it's called. And the F is really weird. So, there you go. All right. So, let's keep going. How many energy levels are in the second principal energy level? 2. Good. So we have n equals 2, so L can equal 1 or 0. All right. Let's keep going. 21. Shape, not the size of an electron cloud, is determined by the electrons. Energy sublevel, right? Good. The letter, number 22, the letter P in the symbol 4p3 indicates what? Shape. Good. The orbital shape. We already determined that from above. Dumbbell shape. Okay? Any questions on the second page here? Any questions on quantum numbers in general? Yep, no? Pretty straightforward, right? All right. Let's keep going. Okay, according to the Aufbau rule, okay? Take a minute to read those. It says, according to the Aufbau rule, an orbital may be occupied by only 2 electrons. Electrons in the same orbital must have opposing spins. Electrons enter orbitals of the highest energy first. Electrons enter orbitals of the lowest energy first. D, good. Electrons enter orbitals of the lowest energy first. Okay? All right, electron configuration. What is the electron configuration of potassium? Take 30 seconds or take a minute to go look at the periodic table and write down the electron configuration. Doing okay? Doing okay? Doing good? Everybody good? Good? Awesome? Awesome. I'm freezing. I've been sitting in here for 2 hours, 3 hours. I'm freezing. Cold, so cold. All right, so let's take a look at this question. What is the electron configuration of potassium? So essentially, we can eliminate these by what it's not. So if you look, that one's wrong. Potassium is 4s1. We can look at the periodic table. So we know it's not going to end with P3, and we know it's not going to end with D1. So it has to be D. Any questions? Nope. Okay. How many unpaired electrons are there in a sulfur atom? So this goes back to our molecular orbital theory type stuff. So give this one a shot. Take a minute to go over this. I suggest you draw the boxes and the arrows. Okay? Where did I put my periodic table? Side. Doing okay? Yeah. All right. We doing okay over here? Mm-hmm. Awesome. All right. Doing okay? How are we doing over here? We doing okay? Doing awesome? Yeah. It's on the Study Union WordPress site. So if you Google UCF Study Union WordPress, it'll come up as the SARC WordPress. Scroll down where it says Study Union materials can be found here. Click on that. Yeah. Yeah.
For the final, Bettina's final particular, how many other concept questions in regard, like to the advanced, how much concept would you say?
I mean, remember, the ACS test is designed to where you take 75 questions in 75 minutes. So can you really do that many math problems in 75 minutes? So my guess is there's a lot more concept there in their math, or they're very simple calculations. Yeah.
Are you going to be going over the most important equations?
Not necessarily, no, but I will be going over some gas stuff after, because those are Patino's questions after. Some of Patino's questions will be gas stuff.
Thank you. I thought the test was only 35 ACS.
35 ACS, yeah, and then 15 of his, or 20 of his now, whatever it is. Okay. All right, let's go ahead and go over this. So we're going to use our boxes and the periodic table. So how many valence electrons does sulfur have? Total valence. It has 6. Good. Remember, if you go with our boxes, this is our 1s, or whatever s sulfur is here. So that's our 3s, and this is our 3p. There are 3 boxes here. 2, 3. Okay, remember there are 6, so we fill in from the S. 1, down, up, down. 1, 2, 3. So we've already used that. There are 6 here now. This is our 3P. This is our 3S. Okay, so there are 2 unpaired electrons. Okay? Everybody get that? All right, let's keep going. So here's a light question. How does the speed of visible light compare to the speed of gamma rays when both speeds are measured in a vacuum? A? The same. Good. They're all the same. The speed of gamma rays and the speed of visible light are the same. They all have the speed of light, 3.6 times 10 to the whatever meters per second. Okay? They're all an electromagnetic wave. All right. Which color of visible light has the shortest wavelength? Okay? So if I'm going on my spectrum from longest, what's the longest? Red. Good. Just remember colors of the rainbow. Red is the longest wavelength. In this case, violet is the shortest wavelength. That being said, what has the most energy, red or blue or violet? I heard some reds and some violets. What has more energy, shorter or longer wavelength? Shorter wavelength. Good. So shorter wavelength has more energy. It has, yeah. Okay? Everybody clear on that? All right. I can skip this one because you really don't need to know that one, nor is it going to be ever tested on. I must have missed that one going through this stuff. The answer to this one is an emission spectrum. So, there you go. All right, let's keep going. Number 29. What categories of elements does an element belong to if it is a poor conductor of electricity? So, do metals conduct electricity? Yes. Do transition metals conduct electricity? Do some metalloids conduct electricity? Yeah. So, it has to be nonmetals. Nonmetals don't conduct electricity. What element has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p2? So take 30 seconds and look that over. 3p2. You doing okay over here? Well. All right, so the answer to this is silicon. Silicone, whatever you think. All right, the trend for atomic size. Atomic size is generally, what if I were to draw the trend for atomic size, here, and here's my periodic table-ish thing. What did I just hit? Okay. There's my periodic table-ish thing. If I were to draw increasing atomic size, where would my arrow point? Where? Bottom left. Good. That's my largest. So small, large. So if we look at this question, it decreases as you move from left to right across the period. Decreases. Okay? Cool? All right. What element in the second period has the largest atomic radius? Take 30 seconds. All right, let's take a look at what element in the second period has the largest atomic radius. So, second period, largest atomic radius is lithium of these. Okay? It's to the left. So, lithium is the answer. Any questions on this page? Nope. All right. The metals in groups 1A, 2A, and 3A, what happens when they're ionized? Do they tend to go negative or positive? Positive, good. So what does that mean about their electron count? They lose electrons, good. So they tend to lose electrons when they form ions. Okay, what is the element with the highest electronegativity value? Fluorine, good. So if I were to draw my trend for electronegativity on my periodic table-ish thing, what is the highest electronegativity? Fluorine, so that's the top right, right? So electronegativity moves this way and this way, I believe. It increases going that way, towards fluorine. Okay? So I can draw my arrow going that way. All right? All right. Which of the following statements correctly compares the relative sizes of atoms to a neutral atom? When it gains an electron, is it bigger or smaller? Bigger. Good. It has more electrons in the cloud, so an anion is bigger or smaller than a cation. An anion is bigger, because it's negative, and has one more electron, than a neutral atom. Okay? Good? How many valence electrons are in an atom of phosphorus? So go on the periodic table and look. Should be 5, right? 5. What is the formula for aluminum oxide? So, let's take a look at this. So we have aluminum. We have aluminum with a charge of 3 plus, and oxygen with a charge of 2 minus. When we bring it down, we bring the numbers down, so we get Al2O3. Those numbers come down next to it. So the answer is Al2O3. Okay? So what is the formula for, extra question? What is the formula for phosphoric acid? Go ahead and take a minute to write down the formula and the Lewis structure for phosphoric acid. What? This isn't a number on there. Extra question. Write down the structural formula and the Lewis structure for phosphoric acid. Yeah.
How are we supposed to know what makes up phosphoric acid? Are you just supposed
Chem 2040.
to? Yeah.
That's fine. It's naming.
Okay, true. Means it has an
oxygen, right? Or no?
It's an oxyacid, yes.
Okay.
I don't remember. I have to draw it out. I don't think so, but I don't remember. How are we doing over here? Good? Good? Yes.
So remember this like thing when you do naming formulas? Which one is it?
I ate something and got sick.
It's 8. If it's phosphate, then it would be phosphoric.
Yep. I ate something and got sick. You doing okay? We're doing okay? Yes? All right. You doing okay?
I think so.
All right. Yeah. On the what? This is, if you go, all right. Scroll under my name. So, there.
Are you sick?
No.
Okay.
I just got some in my throat. Click on that. I've been talking for 3 hours. Yeah, there it is.
All right, thank you.
And the answers are on the last 2 pages. Oh, I'm dying. All right. Oh, hey, jeez. All right. So how many people drew the Lewis structure? Who got the Lewis structure? We got like 3. How many people got the chemical formula for it? We got a couple more. Okay. Let's go over how to do this. So remember acid naming from Chem 2040. We have phosphoric acid. So remember I ate something and got sick, so we have phosphate, PO4 3 minus, and we have H in front of it to make it an acid, so it's H3PO4. That's our structure we're looking for. In order to draw the Lewis structure, what is going to be my central atom? Phosphorus, good. Yeah, I ate something and got sick. So I ate something and got sick. And the other one is I took a bite, ITE, and got nauseous. Okay? So if it was phosphic acid, I guess, it'd be phosphite. So in this case, it's phosphate, so I ate something and got sick. Cool? All right, so that's our formula, and we know phosphorus is in the center because why? It's the least electronegative besides hydrogen. Remember, the least electronegative is in the center because it does not mind sharing its electrons. Okay? All right, so I'm going to put my oxygens, I'm going to write this down a little lower. Just so, all right, I'm going to write this down here, or here. So I'm going to put phosphorus in the center. I'm going to connect my oxygens around it. Oxygen, 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 oxygen. And I'm going to put my 3 H's on any random oxygen, because it's an acid. Okay? So how many electrons are total are in this? So we have 6 valence electrons, I mean. So 6 times 4, 24, plus, I think it's 42. Am I right? So, all right. So a total of 42 electrons. What? Is it 32? Yeah? All right, 32. 32 electrons. So minus our number tied up in bonds. So 2, 4, 6, 8, 10, 12, 14. 32 minus 14 is 18, right? Math. 18. So now I can go ahead and put my lone pairs around everything else. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there is the Lewis dot diagram for phosphoric acid. Don't forget about formal charge too. I'm going to give you another, minute to figure out the formal charge on phosphorus. What? Where? Why? Shows up like that on Google? No, it should be like that.
It should be like that.
Yeah.
What is Google now, bro? I don't know. Just ask.
Because if you put it down, phosphorus has an expanded octet, which it shouldn't.
Oh, yeah.
See what I'm saying?
Yeah, yeah.
There you go. Yeah.
Chain up there, why is that not a double bond? I thought it was 6. It should have like 6 electrons in the outer shell.
Should have 8.
No. Oh, well, yeah, you need 8.
Yeah.
But then,
There are 8 around it.
yeah.
So 8, 8, they all have 8. There are 8 on phosphorus, 8 on oxygen, 8 on oxygen, 8 on oxygen, 8 on oxygen. If you double bonded it, has 6. See? No problem. Yeah.
So I've been doing this based off of like the valence electrons.
Yeah.
So with P, according to this, has 5 valence electrons. So that's why I did a
Yeah.
double bond here.
Is
so
there
that P
a
would have 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6 for the oxygen.
there should be 8 on oxygen, and how many? There should be 8 on all of them.
I'm so confused. I guess I'm
See,
just
there are
doing
8 on this.
Yeah.
There are 10 on this.
I guess I'm just doing it based off of the valence and not the actual atomic number. Okay.
All right, so how do I find formal charge? Valence electrons minus bonding pairs. So bonds, 1/2 bonding electrons minus lone pair electrons, right? Valence electrons minus lone pair electrons plus bonds. Okay, so if I'm looking for how many valence electrons does phosphorus have? 5. Minus lone pair electrons, how many lone pairs are around it? 0. How many bonds are around it? Plus 4. So it has a charge, or a formal charge of 1. 1 plus. Okay, cool. That's formal charge. There you go. Can I remove this? What? Which one? I can do it of these. Those are going to have different formal charges. I'll pick this one. Okay? So we're going to do valence electrons on oxygen. So if we're doing formal charge on this oxygen, we do valence electrons that it brings. So we have 6 minus the sum of lone pair electrons. So 2, 4, 6, or 2, 2, 4, plus bonds, 1, 2. 6 minus 6, 0. Okay? All right. We good? I'm going to go ahead and pull this away. Okay. All right, let's go back to this packet. So number 38, which of the following is not a characteristic of most ionic compounds? So take 30 seconds. It's a concept question. So give it a shot. All right. All right. So which of the following is not a characteristic of ionic compounds? So they're solids. which is not a characteristic, so they are solids. They have low melting points, which is untrue. They generally have high melting points because of their crystal lattice. So that's not true. When melted, they conduct an electric current. That's true because they're ions. They are composed of metallic and non-metallic elements. Remember, an ionic compound is made up of a metal and a non-metal. Cool? All right, let's keep going. Which of the following these do not exist as a diatomic molecule? Okay, so let's take a look. On our periodic table, we have some that are diatomic. So the diatomic ones are, I don't have a highlighter, but hydrogen, nitrogen, down to iodine. Okay, so hydrogen, nitrogen, down to iodine. Those are diatomic. So let's take a look at the question. Which elements do not exist as a diatomic molecule? We know hydrogen's diatomic, iodine's diatomic, fluorine's diatomic, neon is not diatomic. Good. What does diatomic mean? Good. They exist as each other, as two elements together in nature. So for example, H to H. That's how hydrogen exists in nature, as H2. Okay? All right. Why do atoms share electrons in covalent bonds? What's the purpose? Let's take a look at the answers. To become ions and attract each other? No, but what kind of compound, what kind of bond causes that? An ionic bond. Good. Become ions and attract each other, so that's not true. We're looking for covalent. To attain noble gas electron configuration. Yes. To become more polar? Of course not. To increase their atomic numbers? Who cares about that? There you go. Which of the following diatomic molecules is joined by a double covalent bond? So take a couple of minutes, 2 minutes at most, and figure out which one's joined by a double bond. Yeah. Yeah, I can go over hybridization. All right, let's look at these. Which of the following diatomic molecules is joined by a double covalent bond? So nitrogen is joined by a triple bond. Nitrogen. Helium is joined by a single bond. He, I believe. Yeah. Helium is a single bond. Chlorine is a single bond. Oxygen is a double bond. Questions? You just draw out the structure, same as you would do any other structure. And there you go. Okay? So a bond formed between a silicon atom and an oxygen atom is likely to be, for this question, you need the electronegativity chart, which I have to go find. All right, so here are the electronegativities of each of them. We have silicon as a 1.8 and oxygen as a 3.5. So you're going to go ahead and subtract those two. So we get like 1. What do you get? 1.7? What do you get when you subtract these two? 1.3? 1.7? I gotta do it out. You get 1.7. So remember that, okay, we have, let me grab a different sheet of paper. Okay, this has to do with polarity. So we look at our electronegativity chart. Hey guys, can you keep it down a little bit? All right. So we have to do our electronegativities. There'll be a chart provided if you need them. You don't have to memorize these numbers. Silicon is a 1.8 and oxygen is a 3.5. So the bond between silicon and oxygen, we're looking for 3.5 minus 1.8, which equals 1.7. And remember, it's below 0.4 or 0.5, I think, is nonpolar covalent. Between 0.5 and 1.5, it's polar covalent, and above 1.5, it's ionic. So what type of bond is this? This is an ionic bond. Okay? This is polarity, which is chapter 8, if I remember, or 9. Yeah. 1.9 and above. Is it 1.9 and above? My fault. 1.9 and above, so then it's polar covalent. Okay? So it's 1.9 and above, so it's polar covalent, since it's below 1.9. I'll check the answer key. Yeah. Okay, so the rule is, so nonpolar, less than 0.5, I think, or 0.4. It's kind of a gray area. Some books say 0.5, some say 0.4. So between 0.5 or less than, is it polar? Less than 1.9, that it's polar covalent, and between or above 1.9, ionic. Greater than 1.9. Okay? So there's the rule. We have nonpolar covalent as a 0.5, under 0.5, 0.5 to 1.9 are polar covalent, and greater than 1.9 ionic. So this one's a 1.7. So in this case, it is a polar covalent bond. Yes? You will be provided with, maybe not the chart, but you will be provided with the electronegativities you need in order to do this question. You don't have to memorize electronegativities. Essentially, if an electronegativity problem is on the ACS exam. Okay? All right, let's keep going. Can I pull this away? No? I think it's less than. But it's going to be a definite. It's not going to be like on the border, because some books say 0.5, some say 0.4. So it'll be definitely either, Okay? All right. I'm going to go ahead and pull this away. If you have, you can take pictures of all this stuff after. I just want to keep moving through this. Okay? All right, let's keep going. Which of the following covalent bonds is most polar? So I will provide you with the electronegativities. F equals 4.0. C equals 2.5, I think. 2.5. N equals 3.0. H equals 2.1. Okay, so there are the electronegativities for each element given. So which bond is most polar? Take 30 seconds or a minute to do this problem. Oh. You doing okay? Doing okay? Yeah.
With something like this, like we really only have to know the trends on the periodic table, right? Because like if you look at these, that's gonna offset.
Yeah.
And then like fluorine's the most one to the right, so it's just gonna
Well, I mean, you need to know. Well, yeah, they're all to hydrogen, so that
That's
would
what
count.
I'm saying.
Yeah, you only need to know the ones in the periodic, the trends on the periodic table. But I provided you with the electronegativities.
awesome. All right.
All right, let's go over this question. So somebody just said that you only need the trends on the periodic table. You only really need to know the trend on this. Since everything's bonded to hydrogen, everything else would offset. So you just essentially look for the one with the highest electronegativity, which happens to be what? Fluorine. So HF is the most polar bond here. Okay? Questions on this? Everybody good with polarity? So let's do a, well actually, scratch that, that question's in here. This is the question I was looking for. Okay, so we have question number 44. When placed between oppositely charged metal plates, the region of a water molecule attracted to the negative plate is the blank. So take 30 seconds, think about which way is positive, which way is negative, which way the polarity vectors are pointing, then we'll go over it. All right, let's take a look at these. So let's draw out the structure of a water molecule first. So we have oxygen up here, we have hydrogen down here, hydrogen, and two lone pairs, right? Yes? And what shape is this? Bent, good. And what's the bond angle between these two? Huh? I believe it's just under 109.5 or less than 109.5. It's going to be around 107.5. Okay? So you can just write it as less than 109.5. 0.5. That's not what we're looking for here. So we can look at this. Which side's negative on this one? Audience participation. The oxygen side is negative and the hydrogen sides are positive. So we can draw our polarity vectors going this way and this way. So the question states, when placed between two oppositely charged metal plates, the region of a water molecule attracted to the negatively charged plate is the hydrogen region of the molecule. Good, because positive and negative attract. Hydrogen. Questions? Questions? All right, let's keep going. What type of ions have names ending in IDE? Anions, cations, metal ions, only gaseous ions. If sulfur is an ion, what do I call it? Sulfide. If sodium is an ion, what do I call it? Sodium. I call it a sodium ion because it's a positive ion. Sulfur is a negative ion, so it's sulfide. So only anions. Okay? Questions? When naming a transition metal ion that can have more than one common ionic charge, the numerical value of the charge is indicated by C. Good. Roman numeral following the name. Which of the following compounds contains the Mn3+ ion? We can take a look. So remember we have Mn3+, and we have, in this case, we can have O, 2-. We can bring those down, and we get Mn2O3. Okay? If I were to name that compound, what would the name be? If I were to name that compound, what would the name be? You said manganese oxide? What did we say in the question before? Roman numerals. It's transition metal. So we have manganese 3 oxide. Good. If we were to name that compound, it would be manganese 3 oxide. Okay? Let's keep going. Which element, when combined with fluorine, would most likely form an ionic compound? So fluorine. So what type of, so fluorine is a nonmetal. Ionic compounds are made of metals and nonmetals. So that one's a nonmetal, that one's a nonmetal, that one's a nonmetal. Lithium is the only metal here. If I said write out the compound between lithium and fluorine, what would it be? It'd be Li, which has a charge of 1+, F has a charge of -, so it would be LiF. Okay? Which is the correct formula for potassium sulfite? Sulfite, what's sulfite? SO3 2-. Okay? We don't need H's in here, we're just looking for potassium sulfite. So K plus SO3 2-, K2SO3. Questions? All right, let's keep going. What is the formula for phosphoric acid? We already did this. H3PO4. I kind of jumped the gun on that one. What does the ending ite or ate ending in a polyatomic ion mean? It has oxygen in it. Good. Okay? Avogadro's number is representative particles equal to 1 mole. Good. How many molecules are in 2.10 moles of CO2? Let's go ahead and do this out. Let me grab a piece of paper. So we're going to do a little bit of stoichiometry on this problem. So we have 2.10 moles CO2. We have 1 mole CO2 goes to 6.022 times 10 to the 23rd molecules, which equals D. 1.26 times 10 to the 24th CO2 molecules. Okay, so you multiply everything on the top, divide by what's on the bottom. Remember, 6.022 times 10 to the 23rd molecules per mole, or atoms per mole, or whatever per mole. Okay? What mass in grams of 5.90 moles of C8H18, or what is the mass in grams of 5.9 moles of C8H18? So like we did before, we're going to use a little bit of stoichiometry. 5.90 moles C8H18. We use the mass. The mass of that is what? It's 12 times 8 plus 18. What's the mass of this? 114? 114 grams C8H18. 1 mole, or what am I doing? Wrong way. You're right. 1 mole equals 114 grams. Okay, so I'm just going to multiply 5.9 moles by 114 grams, and I should get 5 times this, should get like 679. Okay, remember the units have to cancel down, unlike I did, and equals grams of the substance. All right? This isn't my prettiest work, but I'll have to do. All right. At this point, I'm going to take a break from this packet. I'm going to go over to some gas problems, then we'll finish up with some of these problems. Okay? Let's go over to some gas problems. So this is more of a problem solving rather than concept questions like the other one. This one says calculate the rate of effusion between sulfur dioxide and helium. So I want you guys to take 2 minutes to try to solve this problem, and then we'll go over how to do it. It's rate of effusion, so it's what we just covered. It's chapter 5. It's what we just covered in class. Look familiar? We did this one. How are we doing? Doing okay? You don't know? I got you. Do you have the PowerPoint with you or no? Like the PowerPoint from Patino's class or no?
Oh, we had this.
Oh, okay. Rate of diffusion is rate of A over B equals square root of B over A, molar mass of B over A. Yeah, it's that one. There you go. Doing okay?
Yeah, just actually following what you're talking about.
Gotcha. Nice. We doing okay over here? Yes? Yeah? All right. Doing okay over here? No idea. All right. Do you have Patino's class or you here from Dixon's? Patino's. Okay.
See what he drew on my paper.
What did you draw on his paper?
He drew this on my review paper.
No idea what that is. Anyway. All right. Anyway. All right. So this one is kind of like this is a rate of diffusion problem. So it's rate of A over B equals square root of molar mass of B over A.
You said
Molar mass of B,
over B.
oh, B over A. So B's on top. Molar mass of B.
You want
So in this case, A is sulfur dioxide, and B is helium. So mass of helium, square root of molar mass of helium over square root mass of A, which is sulfur dioxide. Okay? How are we doing over here? Doing okay? Doing good? All right. Yeah.
So if I got 4 for my number, what would that tell me? Which one is diffusing at a faster rate?
So whatever one's on top is diffusing faster than the one on the bottom.
Okay.
Okay? The whole number is going to be, well, we'll go over it. Yes. The problem is I'm not entirely sure. Which ones did he give on your test? Last one. 0? Then 0.
Maybe the second.
No, I mean the last one that included gases. Did he give you the combined gas? You had, yeah. Then it's going to be memorizing them all. Solubilities or rules will be given if you need them. Yeah. Same with electronegativities and things like that. There's an ACS sheet that comes with it. You can look that up online. I'm just not totally sure what's on that sheet.
Okay, but that sheet will be given to
Yes.
Okay.
It's not great, but yes.
Okay. Do you have to memorize all the colors of an ion?
Yes. Those come from 2040.
We didn't have to memorize them.
Well, those come from most professors. Who did you have? Oh, okay. All right. All right, let's go over how to do this question. So we're going to use the formula. Hey guys, hold up. All right, so we're going to use the rate of diffusion between sulfur dioxide, so that's A, this is B, and helium, which is B. So A over B equals square root molar mass of B over molar mass of A. Okay? So what's the formula for sulfur dioxide? SO2. Nice. And helium is He. Is helium diatomic? No. Good. So we're going to use our molar masses. So SO2 over B, He, equals square root molar mass of B. So what's my molar mass of helium? It's like 4.04, right? 4.0, it's like 4. 4.0-ish over my SO2. So what's my mass of SO2? 64. 64. Okay, so if I'm calculating the rate of effusion between this, it's square root 1 over 16, right? If I do my math right, and equals square root 1 over, or just root 1 over 4. Okay? So this tells me that SO2 will effuse at 1/4 the rate of helium. Okay? Yeah, question, not a question, okay. So that is my rate of effusion. Remember this formula? That one will be, I'm pretty sure that one will be tested on because you haven't been tested on it before. There you go. Okay? Can I take this away? Yeah? All right, I've got another gas problem. So this one reads, a sample of hydrogen was found to effuse through a pinhole 5.2 times as rapidly as the same volume of an unknown gas at the same temperature and pressure. What is the molecular weight of the unknown? So remember, we just used this formula, so there's your hint. Take 2 minutes, give this one a shot. I'll put that down so you can see it. There. Doing okay? You good over here?
I think so.
All right. How are we doing over here? Good? Doing well? Same form. Yeah. These are what you think are going to be his questions, or something similar to his questions, because you haven't been tested on this, so I can only assume it's going to be on the final. He looked over these. These also come from the PowerPoint. So they may not be the same numbers. I didn't take it with Patino, no. But I took this course. So I had it with Dr. Hernandez. His tests, well, these are similar to Dr. Patino's. I'd say Dr. Hernandez structures his course different. He's not even giving the ACS tomorrow. No problem. I did have to take the ACS, though. He was required to do it last year. So. The ACS? You have half. I was required to take it all, or very similar to it all. We doing okay back here? Doing good? Yes? Yeah? All right. Yes. It's on my WordPress site, or the Study Union WordPress site. So Google UCF Study Union WordPress. The Sark WordPress will pop up, and then it says scroll down. That's just WordPress. Are you using Google or Yahoo? Who uses Yahoo?
I had a virus, so now.
Oh, okay. Yeah, this is the Study Union, so go up to Chemistry, and then scroll down for my name under 1B. Did you solve it? Oh. How does it occur in nature?
Is this where we use 3RT square root? No.
Same formula as the last time.
Is it?
This is the rate of diffusion, not root mean squared speed. Root mean squared speed. We'll go over it in a minute. Remember the formula. That's the main thing. All right, let's go over this. So we're going to use the same formula as we did for the last one. We're going to use our rate of diffusion. So I'll go ahead and write that down and zoom out a little bit. Focus. Okay, so we're going to use our same formula as last time. So we're going to use A over B equals root molar mass B over molar mass of A. Okay, so we know hydrogen, which occurs diatomically, H2. Refuses 5.2 times faster than our unknown, root molar mass of X over H2. What's my mass of H2? 4. 2, yeah. 2.02. I was like 4. All right, 2.02. So now I can replace this with my 5.2. 5.2 equals root x over 2.02. So I'm going to square both sides now. 5.2 squared is what? 27.04 equals x over 2.02. Okay? So now I'm going to multiply by 2.02, and I should get like 54 point something. 54.08 grams equals X. So that is my molar mass of my unknown gas. Questions? So what we did was we used our rate of diffusion problem. We already were given our rate. We plugged it into our square root. We just crossed them essentially, solved, and you get a molar mass of the unknown one to be 54.08 grams. Okay? Cool? Taking pictures. All right, let's move on. I have another gas problem, if you can see that. It says, what is the root mean square speed of N2 molecules at room temperature? 25 degrees Celsius. Okay. Root mean squared speed. Yes. I wasn't going to go over a Born-Haber cycle problem, no. Because, well, my feeling is, I don't know, it could be there, it's your final exam, this is my disclaimer. My feeling is, you don't have time for one, but that, on the ACS, definitely won't. His portion, however, I don't know. So, that was my feeling on it.
I was just going to ask, like, the only kind of resource I have besides my test is the study guide.
Yeah.
So, like, will the questions be similar to the ones in here? Like,
That's the ACS study guide?
Yeah,
They will be almost exactly to that one.
Because, like, some of them were just really conceptual.
They'll be almost exact to
Didn't
that.
understand.
Right, I know. That's the thing with the ACS. So
He claims that it's easier though, so I don't know what to expect.
remember, he chooses 35 of them.
Oh, he's picking it for us?
Yeah, I believe he picks them.
On mastering chemistry, Patino put up the an ACS practice test.
Yeah.
Is that similar to the?
It's going to be similar.
Okay.
Remember, if he put it up, he hand chooses the questions. So, you know. How are we doing? Root mean squared speed? Root 3 RT over molar mass? Yeah. Molar mass, I think? Yeah. Yeah. I'm coming. Yeah.
The previous problem on the rate of diffusion,
Mhm.
when you have the rate, isn't it the molar mass is the A over molar mass is the B? Doesn't it switch around when you already have the rate?
If you already have the rate, remember that, let me go grab, well, if you already have the rate,
Yeah.
so A over B equals 5.2.
Okay.
So you have A, which is H2, over B, which is our unknown, equals 5.2, which equals, so you can do 5.2 equals H2 over unknown, which also equals root unknown, because they're swapped,
Yeah.
over H2.
Okay. 'Cause when we did them in the textbook, we did it the other way, and that's how we got the right answers.
It's the same, if you look, this is, it's the same thing. I mean, well, scratch that. I don't know exactly what you're meaning by, if it's flipped, it's going to be wrong.
It is.
Yeah.
Okay. 'Cause when we did the textbook problems.
If you flipped, it's going to be the inverse of it.
Yeah.
It's
That means.
because also you have to look, sometimes they say 5 times slower,
Okay.
in which case it would be flipped. If it says 5.2 times faster, which
That's
that
what it
one,
was.
yeah, because I,
slower than-
I did a textbook question on Friday, which
Okay.
was 5.2 times slower or something similar,
Okay.
where it was flipped.
So if it's slower, then it's the other way around.
It's the other way around. It's direct if it's flipped. Because remember, the ratio's flipped
Okay. Yeah.
if it's slower.
Okay, so if it's slower, then it'd be 5.2. 5.2 times slower, then it would be the unknown over the hydrogen.
Yeah.
Or,
Well, no, it'd be the other way around.
Yeah, the way we have it.
The- Because right now, as it is, it's
slower, then it would be just.
yeah, 5.2 times slower. Yeah, the unknown would be on the bottom. Okay.
Yeah. Okay? Yeah,
You've taken the ACS before, right?
I have.
And like, is it similar to your study guide, or is it what would it be compared to like his test?
He
or-
put something on mastering chemistry
Mhm.
to where it's an ACS practice,
Yeah, that.
where it'd be similar to that.
Okay.
It's going to be mixture between this and like that, kind
I
of.
meant like a format, like.
It's conceptual.
Okay.
I mean, most of it's conceptual. There are some calculations on it, but remember the test is designed to where you're supposed to have 75 questions in 75 minutes. So. All right, so this is what is the root mean squared speed of N2 molecules at room temperature, 25 degrees Celsius. So my formula for root mean squared speed equals radical 3RT over molar mass. Root mean squared speed. Okay? So remember, our temperature has to be in Kelvin. Our R is is a specific R. It's 8.31 whatever, 8.314 or something similar, or 413. I'll find it. .314. I knew I had them flipped. Okay, so let's go ahead and solve for this. So we have 3 times our R, which is 8.314, times our T in Kelvin, so 25 plus. This is the different R. It's like, the units are different, so it's like kilogram meters squared rather than like something different. Okay, So remember, our temperature has to be in Kelvin, so it's 298 Kelvin divided by my molar mass, which happens to be 28 grams, but it has to be in kilograms, 0.028 kilograms. Okay? Remember, mass has to be in kilograms. Our R has to be also in it's like kilograms per meter squared over second squared per Kelvin per mole. It's like some weird big unit. Okay? So when we go ahead and multiply that out, we should get the answer in meters per second, which are 515 meters per second. Okay? Questions? People look confused. Yes? I can write them out if you want. Let me get this. So the units for our R, our gas constant, 8.314 kilogram meters squared per second squared. It's Kelvin per mole. That's the units for R. Good? Yeah, it's in a specific unit. And remember, our molar mass has to be in kilograms. If you're doing root mean squared speed, kilograms. Okay? Because it has to do with canceling kilograms in our R. All right, let's keep going. I have some more gas problems. Actually, I have a lot of gas problems. Let's see what I want to do. Let's do this one. This one is similar to one I actually saw in the ACS book and also similar to one he gave you guys. A gaseous compound is 80% carbon, 20% hydrogen by mass. At STP, 546 milliliter, the gas has a mass of 0.732 grams. What is its molecular formula? So take a couple minutes and we'll go over it. Think back to Chem 2040 on this one. Think back to empirical formula.
Here, I don't get in 515.
What are you getting?
Like random number.
When you square root
And then it's here, right?
square root, yeah,
Oh, okay. Never mind.
gotcha. He did this problem, so he did this problem, and that was his answer. So
I got the wait, molecular or the other one is the empirical, right?
yeah,
How does it you get n, the thing you multiply by again? It's like
you need a gas equation.
it's
Okay, let's go ahead and go over this problem. This problem is like an empirical and molecular formula problem, only you have to use, at the end, you have to use a gas equation. Okay, so we're going to do just like 2040. We're going to go we're going to assume, we're going to change the percentages to grams and then solve for moles. So 80 grams of carbon. We have 20 grams of hydrogen. Okay, so I'm going to solve for how many moles are present. So use your molar mass, 12.01, I think, grams of carbon, 1 mole. When I get this, what do I get? I'll solve the other one first. 20, 1.01. We have 80%, 20% hydrogen by mass. Okay, so 1.01 grams, 1 mole, which equals, this one's going to be close to 20, and that one's going to be what? What's 80 divided by 12? 6.661. 6.661 moles, and this one's going to be like 20. One 9.84 moles. So I'm going to divide by the smallest. So in this case, it's 6.661 moles equals 1. Divided by 6.661 moles. When I do this, what do I get for this? 3. We get 3. So this means there's 1 carbon. So the formula is C. And then H3. Okay, that's the empirical formula. Okay, so there are 3 H's and 1 carbon. Cool? Now we need to find the molecular formula. So I'm going to use a gas equation. It's derived from PV equals nRT. So I'm going to do molar mass equals GRT over VP. So molar mass equals great vice president. See what I mean? Molar mass, great vice president. All right, so now I just plug in and solve for my molar mass. Equals my grams, which is up here. You can still kind of see. 0.732 grams times my R, which is the normal R, 0.0821 times temperature. What does temperature have to be in? Kelvin, good, and at STP it's 273 divided by my volume, which is in liters. So volume in this question is 546 milliliters. In this case, it's 0.546 liters times P, which is standard pressure, which is 1 atm. Okay, and when I solve this, what do I get? Can someone go ahead and do this for me? Five, 4, 6. 30.05, 30.05. So that's my molar mass. Okay, what's the molar mass of my empirical formula? So it's 12 plus 3, 15. It's like 15.03, 15.0, it's actually 15.05, I think. So we're going to divide 15.05, or divide the molecular weight by the empirical weight, 15.05, which equals 2. So I'm going to multiply every atom or every element in my empirical formula by 2, and I get a molecular formula of C2H6. Questions? I know there's a lot there. Yeah. It comes from PV equals nRT. Yes. The 15.05, that's the molar mass of it. This is grams per mole. I forgot to put my units. G per mole. Questions? Otherwise. So we get our multiplier from our molar mass divided by our empirical mass, and then multiply everything that's in that formula. All right? Okay. Let's keep going. I'll do one more gas problem, one more from the packet, and then I'll open it up for questions. Sound good? Yeah? Okay. Scratch that. I'm going to do 2 gas problems because I think these are important. So this one should take you no more than a minute and a half. Calculate the pressure exerted by 84.0 grams of ammonia in a 5.00 liter container at 200 degrees Celsius, behaving ideally. So take 2 minutes, think about this one, then we'll do one more that's related to this question. Um, 0.0821.
This is the constant you said, right?
I don't know. Yes? Yeah. Some professors do, some don't. Okay, so this one's a straight PV equals nRT problem. So ideal gas equation equals nRT. Pressure, calculate the pressure, so that's what we're looking for. Exerted by 84 grams of NH3, so let's plug in what we know. So we have pressure times our volume, which is 5.00 liters, equals N times R, 0.0821 times our T. What's our T? 473 Kelvin. And we have to find N, which is what? Moles. Moles. Good. So we're finding moles of NH3, 84.0 grams of NH3. We use our molar mass, which is what? Molar mass is like 17 grams, 1 mole, which equals what? What did you say it was? 4 point something? 4.94 moles. So this is 4.94. Okay, so now you just solve across, and pressure equals what? What did you solve for? 38.36 what? ATM. Does everybody agree? I haven't done this. I'm going on somebody. Yeah? Okay. So this one's PV equals nRT, 38.36 ATM. Questions on this? Straight PV equals nRT. Now, do this one. Calculate the pressure exerted by 84 grams of ammonia in 5 liters containing 200 at 200 degrees C, not behaving ideally, using van der Waals equations. So here's your A and here's your B. What? I'm not positive, but if this one, again, this is my disclaimer. I'm not positive on this one. I would give this if I were giving the exam because it is a pretty long equation. So, but again, I don't know. The best person to ask is him. What is the equation? Okay, I'll write it down. Yeah. Somebody say my name? It was weird. All right. That's van der Waals equation. All right, let's go ahead and go over this, and then I'll open it up for questions. So calculate the pressure exerted, same question as last time, just it's not behaving ideally. What's the difference between an ideal gas and a real gas? What? That's true. But conceptually, what's the difference? What? Good. Real gases, in ideal cases, we don't count the attractive forces between gas molecules. We just think of them as going in straight lines. With real gases, we count the attractive forces between the two. That's what the A and B corrections count for. So we're going to use N, which was like 4.94. 0.94, that's moles, times our R, 0.08221. I'm totally going to run out of room. 473 equals 5 minus N. 4.94 times my B, which is 0.0371. And this is multiplied by 4.94 squared times A, which is 4.17, divided by my volume squared, which is 25, plus my pressure, which is pressure exerted by pressure, which is what I'm looking for, P. Okay, so I am going to go ahead and solve for pressure. So you multiply these together, multiply those, subtract, multiply, subtract, add, and then eventually get pressure down together using algebra. And I should get pressure equals 38.4 atmospheres, which is very similar to the one prior. We just get minor corrections. Okay? All right. At this time, I am going to open this up for questions. Anything you guys want, you can come up. I'll be right in this chair because I haven't sat in 4 hours. So, I just want to thank you guys for coming and good luck on your exam. I know you wanted to go over. Let me see.
Number 66.
Let me shut this off. Yep, no problem. Let me just shut this off.